In this session, we're going to review the substitution method. Here in this first example, we have a system of two linear equations in two unknowns. So one thing that we can notice here, looking at this first equation, we could rewrite this pretty nicely as y is equal to 5 minus 3x. And once we've done that, we could take this formula we have for y and dump it in to the second equation that we had. So wherever we had a y, we're going to replace it by 5 minus 3x. So if we did that, we're going to still have the 2x plus 5, but where I once had a y, I am now going to have a 5 minus 3x, and all of this would be equal to -1. Now, if you look at what you have here, we have an equation that just involves x here. It's a linear equation in one variable. We should be able to solve this. So in order to solve this, though, we might need to clean up what we have here. So we have to distribute the 5 in. 5 times 5 is 25. 5 times minus 3x is minus 15x. Now let's group like terms. So it looks like we have a 25 minus a 13x is equal to -1. Now let's subtract 25 from both sides. If I did so, I'd have minus 3x is equal to -1 minus 25, which is going to give me -26. And then I could divide both sides by -13. And find that x is equal to 2. Now that I figured out what x is, I could go back into any of these formulas and figure out what the corresponding value is of y. For instance, I already have y is equal to 5 minus 3x, so I could use that and figure out what y is. So y would be 5 minus 3 times 2, which is going to be 5 minus 6, which is going to be -1. So we see here that our problem, this system of two linear equations in two unknowns, we have a solution that x is equal to 2 and y is equal to -1. Okay, in this example, though, I have a system of three linear equations and three unknowns. So this is a bit trickier, but we can still use the substitution method in order to do this. So if I'm looking at these three equations, one is a little bit simpler than the others. So maybe I'm going to start with this third one, and I could solve it for z or I could solve it for y. It doesn't particularly matter. Let's say I say that y is equal to 3 minus z. Now I have an equation that I can plug in and make everything look a little bit better. So for instance, if I start off with this top equation now, everywhere I had a y, I'm going to dump in a 3 minus z. So what would that leave me with? I'd still have an x, and I'd have a plus y. So my y I'm going to replace with the 3 minus z. And then I still have this plus 3z is equal to 6. Okay, so we could group like terms here. I have an x, I have a plus 3, I have a minus z and a plus 3z. So those two are going to combine to give me minus 2z. And this is going to be equal to 6. So if I wanted to solve for z or solve for x, I could do either of these things at this stage. So let's solve for x. So if I were to do that, I'd have 6 minus 3 minus 2z. So I would get 3 minus 2z. So now I know how to write y in terms of z. I also know how to write x in terms of z. So we could take our other equation and dump in what we know about how to write x in terms of z and y in terms of z. So if we're doing this, we're going to have a 2 times x. Well, x we found happened to be 3 minus 2z. and we have a plus y. Well, y we found was 3 minus z. We still have a plus 2z, and all of this stuff is equal to 6. Now, we have a kind of complicated looking expression, but note here, this is a linear equation in one unknown. The only thing that we have in this is going to be z. So let's distribute. So a 2 times 3 is going to give me a 6. 2 times minus 2z is going to give me minus 4z. So I still have this plus 3 minus z plus 2z is equal to 6. Now let's group like terms. So it appears that I have a 6 plus a 3. Those are going to combine up to give me a 9. I also have a minus 4z, a minus z, and a plus 2z. So those are going to combine up to give me a minus 3z. And this is equal to 6. So I could subtract 9 from both sides at this stage. If I did so, I'd have minus 3z is equal to 6 minus 9, or negative 3. And if I divided both sides by by negative 3, I would find that z is equal to negative 3 divided by negative 3, or would be equal to 1. Now, I have what z is, and I could use those two other formulas I had to figure out what the corresponding values of x and y are. So for instance, I knew that y was equal to 3 minus z, and if z is equal to 1, that would make my value for y equal to 2. I also had that my x was equal to 3 minus 2z. So I'd have a 3 minus 2, and I'd see that my x is equal to 1. So my final solution here, I'd have x coordinate 1, y coordinate 2, and z coordinate 1. And this would be the one point that would solve this system of 3 linear equations in 3 unknowns.